Hello students, in this video I want to explain about rational expressions, and in this case we're going to explain the simplification, multiplication and division of rational expressions. Well, first we must define what is a rational expression. A rational expression is an expression of the form p over q where p and q are polynomials and q is not equal to 0. This condition of q being not equal to 0 is because, of course, if q is equal to 0, then the expression is undefined because the division by 0 is not defined. So examples of rational expressions, we have expressions like minus 6x over x to the third plus 8, 9x over y plus 3, 2m to the third over 8. All these are examples, so we have infinite examples of rational expressions, of course. Now, one of the first skills, right, when we're working with rational expressions or with any kind of expression is to find the numerical value of the expression for given values of the variable. This is basically what we call to evaluate the expression. So when we evaluate an expression, what are we doing is just finding the numerical value of the expression for given values of the variable. In this case, we're going to find the value of the rational expression when x is equal to and when b is equals -3. Well, let's start then, when x is equals 2. So when x equals 2, we have that my expression there is x squared minus 4 over 2x plus 1. As we substitute the x by 2, we get 2 squared minus 4 over 2 times 2 plus 1. What is 2 squared? 2 squared is 4, so we get 4 minus 4 over 2 times 2 is 4 plus 1. 4 minus 4 is 0 over 4 plus 1 is 5, and 0 over 5 is going to be 0. So here we get, that when in this case x is 2, the value of the expression is 0, right? So what are we doing here? We're just evaluating the expression at x equal 2, and what we're doing is basically substituting the x by 2 and then calculating the value of the expression. Let's see a second example. There is when x is equals -3. And when x is equals -3, we have that my expression there is x squared minus 4 over 2x plus 1 becomes now -3 squared minus 4 over 2 times -3 plus 1. -3 squared will be 9 minus 4, and then 2 times -3 is going to be -6 plus 1. 9 minus 4 is going to be 5. -6 plus 1 is going to be -5. And then we have 5 over -5, which is going to be -1. So when x is -3, in this case, my expression will be equal to -1. It will be equal to -1. So this is, what to find the numerical value of the rational expression is. Now, the second important skill here is to find for what value of the variable the expression is undefined. So which are the steps? What is the procedure when we want to find for what values of the variable the expression is undefined? Well, the first would be to set the denominator of the rational expression equal to 0. We will solve then this equation, right? And the solution of the equation are the values that make the rational expression undefined. So the expression, the value of the expression cannot be equal to these values that we found after solving the equation. Let me give you then a couple of examples. They say find any value of the variable for which each rational expression is undefined. write the answers with the symbol not equal to. So basically, what we have to do based on this procedure is to get the denominator, right? So the expression below the fraction bar, and we will make it equal 0. So we're going to say for this first example, 3x minus 4 equals 0. After that, we're going to solve this equation. So when we solve the equation now, of course, we're going to be adding 4 to both sides, right? So we're going to have, of course, 3x. Negative 4 plus 4 will be 0, and then 0 plus 4 will be 4. Now we're going to be dividing both sides by 3. And when we divide both sides by 3, now 3 over 3 will be 1. So it will be 1x, which is x, and then we get 4 over 3 here. So now we know that x cannot be equal to 4 over 3, right? Because if x is equal to 4 over 3, then in this case, the expression would be undefined. Let's do the same for the second example. In my second example, the expression in the denominator is a quadratic expression. As we have a quadratic expression here, then we need to factor this expression as soon as we make it equal to 0 to solve, because it becomes a quadratic equation. So we say m squared plus m minus 6 equals 0. So factoring, we get now factors of m squared are m and m. Then now which are the factors of negative 6 with a difference of 1? This would be 3 and negative 2. Because remember, 3 times negative 2 is negative 6, and 3 minus 2 would be the coefficient 1 invisible that you have here in front of this m. Now, when you have the factors, you can double check. You can say m times m, m squared, m times minus 2m, plus 3 times m, 3m, minus 2m plus 3m is 1m, 3 times negative 2, negative 6. Now you make each factor equal 0, so m plus 3 is equal 0, so you get that m is equals minus 3, so subtracting 3 from both sides. Then m minus 2 is equal to 0, so adding 2 to both sides, you get that m is equals positive 2. So now you know, after solving this equation, you know that your variable m cannot be equal to minus 3, right? And your variable m cannot be equals to 2. Why? Because if m is equal either to minus 3 or to 2, then this expression would be undefined, right? So that is the procedure to determine when the expression is undefined. The next that I would like to explain is what to write the expression in lowest terms is, and how we can write the expression in lowest terms. So lowest terms, the definition of lowest terms is this. They say a rational expression p over q, where q is not equal to 0, is in lowest terms if the greatest common factor of its numerator and denominator is 1. So the expression will be in lowest terms when there is no common factor other than 1 in your numerator or denominator. They have then a fundamental property of rational expression that say that if p over q, where q is not equal to 0, is a rational expression, and if k represents any polynomial where k is different of 0, then the following holds true. P times k over q times k is the same that p over q. That means you can simplify the factor k, right? And the expression you get is equivalent, right? And then we have the procedure to write a rational expression in lowest terms. So they say factor the numerator and denominator completely, and then use the fundamental property to divide out any common factors. Well, basically, I will just look at the expression that I have over here. They say write each rational expression in lowest terms, and then I will just work first with my numerical factors, and I will later work with my variable factors, right? So in this case, what I have is a monomial over another monomial. So my rational expression is made by the monomial 18r to the third divided by the monomial 6r. So in this case, what I have to do is just to first find out if there is a common factor between my numerical factors. So I have 18 and 6. Obviously, uh, 18 is divisible by 6, so 6 divided by 6 would be 1, and 18 divided by 6 would be 3, right? Because 6 times 3 is 18. So I know that now the numerical factor resulting here will be 3. I will do the same analysis now for my variable factors. So I have r to the third over r. R is the same that r to the 1. Using property of exponents, when we have a quotient of two exponential expressions with the same base, we subtract exponents. So r would be r to the third over r to the 1 would be r to the power of 3 minus 1, which is r squared. So what is going to be the result of this? 3r squared. So when you write in lowest terms 18r to the third over 6r, the result will be 3r squared. Now, the next example involves a polynomial over another polynomial. So the polynomial in the numerator is a binomial. The polynomial in the denominator is another binomial. For the polynomial in the numerator, we can recognize, that is a difference of squares, right? Why? We have two terms. Both terms are perfect squares, and the sign between both is negative. So we can factor this following the rule of the factorization for the difference of a square, which is this. A squared minus b squared is equal to a plus b times a minus b, right? So I will be factoring here this 9r squared minus 4s squared. The factorization of this would be 3r plus 2s and 3r minus 2s, right? You can now multiply to make sure that it's correct. So you say 3r times 3r, 9r squared, 3r times minus 2x, minus 6rs, 2s times 3r, positive 6rs, they cancel, and then 2s times minus 2x is minus 4s squared. Below, I have common factor 3. So we factor the common factor 3 out, and when I factor 3 out, I get 3 times 9r divided by 3 will be 3r, plus 6x divided by 3 will be 2s. So we get 3r plus 2s times 3. So now we're going to cancel out the common factors, right? So 3r plus 2x of the numerator will be canceled with the 3r plus 2x of your denominator. So after simplifying, the result will be 3r minus 2s over 3. And here you have the result after simplifying, the rational expression. So there is a difference when what you have is a monomial over another monomial, because in this case you didn't have to do any factorization. And then there is completely different approach, right, when you have a quotient of two polynomials, because then you must do the factorization of each polynomial. The next I want to explain is something that is super important when we are simplifying, that is the quotient of opposites. They say that if the numerator and the denominator of a rational expressions are opposites, such as in x minus y over y minus x, then the rational expression is equal to minus 1. So this is important to remember whenever we are just working in the simplification, multiplication, or division of rational expressives. So we have this case where they give us this quotient and we have to write the expression in lowest terms. So basically we have to simplify the expression. So we immediately understand or recognize that we have a quotient of two binomials, right? And in both cases the binomial have a common factor. So the binomial in the numerator have a common factor q, so we factor in q out. So dividing q squared by q, you will get q here. Dividing 4q by q, you will get 4. So q times q minus 4. Now your denominator is 4q minus q squared. So again, you immediately realize that there is a common factor q, so you factor q out, right? And then when you factor q out, 4q divided by q would be 4 minus q squared divided by q would be q. right? Of course, q over q cancel out here. And then what you have is just q minus 4 over 4 minus q. Q minus 4 over 4 minus q are just opposites. So you will cancel them out, but you will immediately multiply times negative 1, right? Because when you cancel opposites, you get minus 1. That means that now as you have cancel here, q over q, which is 1, and you have cancelled q minus 4 over 4 minus q, which is minus 1, the result in this case would be just minus 1, right? The result in this case will be minus 1. So this is super important to remember whenever, we're working in the simplification of rational expressions. Whenever you find opposites, you can apply this rule. The next that I want to explain is the multiplication of rational expressions. So they say that the product of the rational expressions P over Q and R over S is defined as follows. P over Q times R over S is equal to PR over QS. In other words, to multiply rational expressions, you multiply the numerators and you multiply the denominators. Of course, you must always write your final expression in lowest terms, right? So in this case, what I prefer to do before performing the multiplication is to simplify all those common factors that we can simplify, right? So when I have the expression 15a squared over 14, times 7 over 5a, right? I immediately find out, that 14 and 7 share a common factor 7. So 7 divided by 7 would be 1, and 14 divided by 7 would be 2. I also realized that we have 15 and 5. So 5 divided by 5 would be 1, and 15 divided by 5 would be 3, right? So now in terms of my numerical factors, what we have is 3 times 1. Below I have 2 times 1. And then I have my variable factors, a squared over 8. A is a to the 1, so when I apply, in this case, the quotient rule of the exponential expression, so I say that a squared over a to the first, right, or 8 would be a to the power of 2 minus 1, which is a to the 1, which is a. So we have another factor a here. So when now we multiply, we get that 3 times 1 is 3 times 8, 3, 8, and below 2 times 1 is going to be 2. So when I multiply, in this case, what I get is just 3a over 2. So what I decide to do, I decide to simplify before multiplying. You can also multiply and simplify at the end. It's up to you really, right? Whatever you feel better, whatever you feel easier, so whatever is more comfortable to you. Now, I have this other case here. There is, in this case, a plus b squared over 5 times 30 over 2 times a plus b, right? So, well, if I have a plus b squared, remember that a plus b squared is a plus b times itself. So it's a plus b times a plus b, right? Over 5 times 30 over 2 times a plus b. I decide in this case just to write a plus b squared as a plus b times a plus b to help you, realize, right, that a plus b squared is the product of a plus b times itself. So you have two factors a plus b at the numerator of the first rational expressions. You will simplify one of the factors, a plus b, with the factor a plus b you have below, right? And then we're going to simplify, the 30 and the 5 because they are both divisible by 5. So 5 divided by 5 would be 1, and 30 divided by 5 would be 6. And then we're going to simplify 6 and 2, right? So 2 divided by 2 would be 1, and 6 divided by 2 would be 3, right? So now we're ready. So what we have in the numerator In my numerator, I have the factor a plus b, and I have this factor 3. So I get 3 times a plus b. And what about the denominator? In the denominator, I don't have any factor other than 1. So it's going to be 3 times a plus b over 1, which is going to be 3 times a plus b. Right? So this is how you, in this case, perform these multiplications. You simplify first, and then you later, uh, multiply numerator, and denominator times denominator. And finally, we get here to what is the division of rational expressions. So how we divide rational expressions? They say that if P over Q and R over S are any two rational expressions where R over S is different of 0, then the quotient is defined as follows. P over Q divided by R over S will be the same as P over Q times S over R. So S over R is the reciprocal of R over S. So basically, what you're doing is, when you face a division, right, you convert that division into a multiplication, right? You will convert that division into a multiplication, but to do that, you must flip the divisor. So the second fraction, the divisor in this case, R over S, becomes S over R, right? So to convert the division in multiplication, you must find the reciprocal. You must multiply by the reciprocal of R over S, which is S over R. So let's then try to solve it. This exercise here where they say divide and write each answer in lowest term. We always have to write the answer in lowest terms. So the first I'm going to do before trying to do any other thing is to rewrite this division as multiplication by the reciprocal of the divisor. So we say 35 q over 8 over 9 q to the q to the 8 and then below q to the 5 times, then I have 10 q to the power of 5 divided by then 25 q to the power of 6, right? So as you see, now I don't have a division anymore. What I have here is a multiplication, right? And what I did, I just kept my first fraction as it was given, right? 35 q to the power of 8 over 9 q to the power of 5, and I have multiplied this times the reciprocal of the other fraction, or the other rational expression, which is 10q to the 5th over 25q to the 6th. Now, once I have this, I am ready to do the multiplication. So to multiply, I will simplify first. So I know that in this case, 25 and 35, they are both divisible by 5. So dividing 35 by 5, we get 7. And dividing 25 by 5, we get 5 here. Okay. Now 10 and 5 are both divisible by 5. So you divide 5 by 5, you get 1, and you divide 10 by 5, and you will get 2 over here, right? So I have the numerical factor 7, 2, 9, and 1. I cannot basically simplify any of them. So we get 7 times 2. Above, below, I have 9 times 1. And then let's see what happened with my numerical factors. I have q to the 8 times q to the 5th in my numerator, right? So this would be q to the power of 8 plus 5, which is q to the 13. My denominator is q to the 5th times, I have this other factor q to the 6, right? This is q to the power of 5 plus 6, which is q to the 11, right? And then now we can just, of course, divide q to the 13 over q to the 11. So q to the 13 over q to the 11 is going to be q to the 13 minus 11. So this would be q squared. So what we get is a factor q squared here in this numerator So the result would be 7 times 2, 14, q squared over 9 times 1 is 9. So my answer in this case, when I perform this division, is going to be 14 q squared over 9. So again, super important till you just get enough skills. I will always recommend you guys just to do the simplification of your numerical factor first, and then later take the variables, right? Apply the rule of exponents that you know, the product rule and the quotient rule, right? And try to like consolidate, you know, those exponents that are in the numerator, or sorry, or those exponential expressions that you have in the numerator, an exponential expression you have in the denominator, you know, and then at the end, using the quotient rule, you can just simplify all of them. Well, we have one more example, one final example. In this final example, we have 4n plus 16 over 10 divided by 3n plus 12 over 18. So what do we have to do? We have first to write this as a multiplication. So we say 4m plus 16 over 10, and then times, and then I flip the second one. I say 18 over 3n plus 12, right? Now, once I just convert the division and multiplication and I multiply by the reciprocal of the divisor of the second rational expression, right? Then I will now factor. I realize that for n plus 16, we have a common factor of 4. I factor the 4 out, so I have 4 times n plus 4, right? Over, then I have 10 below, times 18, and then 3n plus 12. I realize that we have a common factor 3, so I factor 3 out, so I have 3 times n plus 4 again. Obviously, I will simplify this n plus 4 with this n plus 4, so it becomes 1 and 1. And now I will just work to simplify the other, the numerical factor that I have. So in this case, 18 and 3, this would be 1 dividing by 3, and this would be 18 divided by 3 would be 6. I will also simplify the 4 and 10. So dividing both by 2, I will get 2 here, and it will get 5 below, right? So I double check. I cannot simplify 2 with 5. I cannot simplify 6 with 5. I cannot simplify 2 with 1 or 6 with 1, of course. So we are ready to say that the result in this case would be 2 times 6 over 5 times 1, which is 2 times 6, 12 over 5 times 1 is 5. So my answer in this case would be 12 over 5. Again, I want to highlight the difference between these two exercises. In the first case, both rational expressions were made by monomials. You know, in this case, in the numerator of both rational expressions, what I had were just two polynomials, two binomials. So that's why in this case I had to do a factorization. So I did a factorization by factoring out the greatest common factor. So basically, my dear student, with this I have explained different examples of how we simplify, multiply, and divide rational expressions. I really hope you know that with this explanation you are going to have a much better understanding of this topic, and you will be ready then to go over our next topic, that will be the addition and subtraction of rational expressions with the same or different denominators. Thank you so much for your attention, and I will see you in a future video.